Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome back to my section again. So I'm Rhiza Fitri Salsabila, as you already know. So today I'm gonna deliver about some materials which is about the sample machines. So as you can see from the picture, this is the one that I point out. This is the examples of sample machines. All of it is included as an example of sample machine. So that's why I attach it in the first slide. So yes, the picture say that it is about the sample machines and it is arranged by me, by Rhiza Fitri Salsabila. So let's dig in. Okay, first thing first, I would like to talk about the definition of simple machine. So according to Wikipedia, simple machine is the simplest mechanism that use mechanical advantage to multiply force. So what does it mean by multiply force? So you can actually move something that is larger that requires a large force within a small number of force. So just imagine that this simplest mechanism multiply your force and then multiply your work. So you can move, for example, you can move a large thing to within the small work, within a small force. So that's what it means by multiplying the force. And then next, this is a very crucial hint. This is about the principle. So the principle of simple machines, let me read it for you first. So principle of simple machine is a machine produces force and controls the direction and the motion of force, but it cannot create energy. So a machine's ability to do work is measured by two factors. The first factor is the mechanical advantage, and the second factor is about the efficiency. So how to judge which the machine is good or not? It's about the mechanical advantage and efficiency. If the mechanical advantage and also the efficiency is good, then the machine is good. That's the key factors and also the principle of the simple machines. And then next, we have the main examples of simple machines or main forms of simple machines. The first one is we have inclined plane. You can see my arrow, it's pointing out to the inclined plane, which is in Indonesia, we know it as bidang miring. And then the next one is the lever, or in Indonesia, we know it as tuas. And then the next one is wedge. For the wedge, this is the wedge. It's very easy. It's an axe. And then the next one is wheel and axle. It's very easy too. You can find it anywhere. And then the next one is the pulley. And then the last one is the screw. Please be careful with your pronunciation and also the meaning behind the word, because the screw in here is the screw noun screw, not the other words, okay? And then next, let me explain about the type of simple machines one by one. But the first, we're going to talk about the inclined plane. So for the inclined plane, we have this picture of a tram. It's a tram in Berlin. I took the picture about the tram in Berlin. You can see that the track is really inclined and very slope. So what does it has to be this way? So inclined plane is a plane that offers a mechanical advantage in that the force required to move an object up the incline is less than the weight that is being raised. The steeper the slope or the more inclined it is, the more nearly the required force approaches the actual weight. So this is a very complicated phrases. So to make it easier for you to understand, so it's actually a very inclined track. So if you make it like very inclined, the more inclined it is, the more easier it is to move. Why? Because you can cut your work to the very bare minimum point, because you don't need to push it because it is already inclined and it will move from the bottom of the places to the top of the places. So that's what it means by these very long phrases. And then the next one is we're talking about lever. So lever, it is very, is it interesting actually? Lever is very interesting for me. So a lever is a bar or a board that rests on a support called a fulcrum. A downward force exerted on one end of the lever can be transferred and increased in an upward direction at the other end, allowing a small force to lift a heavy weight. So that's the point, to lift a heavy weight by allowing a small force. So a small force can lift a heavy weight. That's really amazing. So lever has three kind of types. The first one is the first class, the second one is second class lever, and the third one is the third class lever. How to differentiate it? So how to differentiate it is you can see where is the pivot or the fulcrum, because fulcrum is the one that is supporting the lever. You can see that the first class lever, you can see the pivot is in the middle of the board or the bar. The pivot in the second class lever is in the left side of the bar. And then for the pivot in the third class, you can make a difference. You can differentiate it by the where you can find the effort. So for the effort in the second class lever, you can see this is at the edge, not in the middle, at the edge of the board or the bar, while the effort in the third class lever is in the middle of the bar. For the first class lever, the examples is scissors. You can see that there is scissors. The second class lever, you can see that this is a like a trolley. Trolley is a second class lever. And the third class lever, you can find it in the barbecue tongs. Barbecue tongs is a third class lever. So we're going to move on to the next topic. It's about the wedge. So a wedge is an object that tapers to a thin edge. So it's basically separate one thing into two or three or more parts. Pushing the wedge in one direction creates a force in a sideways direction. It is usually made of metal or wood, and it is used for splitting, like I said before, lifting, or tightening, as in securing a hammerhead onto its handle. So this is what you call a wedge. So it's basically to separate things to make it easier for you to understand. This is an axe, and an axe is the easiest example of wedge, which you can find like literally everywhere, even around your house. But be careful, do not use it for anything aside than splitting woods and something beneficial. And then next, we have wheel and axle. So a wheel and an axle is made of a circular frame, which is the wheel, that revolves on a shaft or rod, which is the axle. So imagine this is the wheel. You can see this is the wheel, and this is the axle. So the wheel will move based on the axle. Can you imagine this is the wheel? It will like turn it around based on the base, which is the base is the axle itself. So, in its earliest form, it was probably used for raising weights or water buckets from wells, of course. Its principle of operation is best explained by way of a device with a large gear and a small gear attached to the same shaft. You can see that this is a wheel of a bicycle. You can see that this is the wheel, exactly, very clear, and the axle is in between the chain. Can you see this is the wheel and axle? So wheel cannot move without axle, and also axle cannot move without wheel. So it needs to be like a one package. And then we have the next one is the very interesting about pulley. So this is pulley, the one you can find in your house at the top of the wall. So a pulley is a wheel that carries a flexible rope, cord, cable, chain, or belt on its rim. Pulleys are used singly or in combination to transmit energy and motion. You can see that the first picture, this is a single pulley because you only use like one cable and then it turns out all good, all perfect. Uh, it used at the, what is it, the fishermen when they want to take the fish, all of the fish onto their boat. And then this is also the single pulley, but there are like second pulley. I forgot to attach the picture. So the second pulley is like this one is the first pulley and this one is the second pulley. So they attach together and they can move like more larger thing. And then next we have this screw. So screw, back at it again. Please be careful with how you pronounce the screw because it may lead to something that's bad words, of course. So this is the screw. This is the actual screw, so you can see it. So a screw is actually a usually circular cylindrical member with a continuous helical rib used either as a fastener or as a force and motion modifier. What does it mean by a fastener? What does it mean by motion modifier? So motion modifier and a fastener is actually what made the screw as the screw. So a fastener, you can see that if you attach the screw onto the woods, it would make the woods like become very useful. That's why it's called by the fastener. And also the motion modifier, you can, for example, this is a stick of woods, this is a stick of woods. If you attach it like this, you need a screw in this point, right? If you attach the screw in this point, you make the two sticks into one stick and they can be functionized as a different function. With two sticks and two sticks into one form, the function would be very different. That's why motion modifier. So you can modify it. And then that's the type of the simple machines. We're going back to the next topic. It's about the 3 ways of how simple machines can make our life easier. So yes, simple machine should make our life easier because that is what is the function of machine actually is to make our life easier. Why do we make a machine if it makes our life become more complicated, right? So, and then the last one, this is the very last one. Okay, the very last one is the daily basis example. So daily basis example is actually a daily activity of simple machines that you can actually find, that you can find literally in your surroundings, like in your environment. So the first one is can you guess what is it? Yes, it is pulley. It is pulley, the one that I have interest in for so long. So this pulley, the name of this pulley is a chain hanging. It's a chain hanging, clearly why the name is chain hanging, right? So this chain hanging, the function is to redirecting tension and helping the construction site to build high buildings. So they kind of put the things in the chain hanging and then they put it into the high building. So it's very easy because you can redirect the tension and then you can carry large things and then put it on the high building without any artificial effort, any additional effort that's needed. And then the second one, in the middle one, it is a train track. Yeah, this is a train track. You can see that the track is in an inclined plane. So it's an example of inclined plane. So the function is reducing the amount of work and directing the road to reach the top of the peak. It's actually the same principle as the tram case before. So the tram and also the train track in this picture is actually the same. Why? Because it moves basically anything within that train to the peak of the mountain. Or else, if you don't use the inclined plane, you need to climb the peak, the mountain. You need to climb it's the mountain itself to reach the peak, right? But with inclined plane, you can just make the train walk down the isle, and then it will reach the top of the peak. And then the last one, it's about the cooking knife. You can see that the cooking knife is perfectly sharp. So the function is, it's an example of wedge. Yes, it's an example of wedge. It's very clear. The function is to separate two objects and making the work easier by directing the energy into one sharp edge. What does it mean with one sharp edge? This is the edge. You need to see my arrow. This is the edge, and it's very sharp. And you push your force into one edge like that. So you focusing your energy and your work into one edge. So the energy is become more stable and focused so you can separate things easily. That's the function of a wedge. So I think that's all from me. And thank you so much for watching my presentation and also listening to until this point. I really, really hope that I could help you with something, at least with related with some machines. And I hope in the future you can apply this knowledge because it's very close with our daily basis. So yeah, thank you so much. And if you have any question, just drop your question in the comment down below. And don't forget to stay hydrated and see you again. Bye bye.